Welcome back to Generative Components and Ecosystem Building Designer Integration. In this session, we will focus on laying out spaces using the space node. We will cover laying out spaces and then linking the space layout to existing geometry, modifying some of the spatial parameters of the space node, and ultimately reporting on spaces. So why might you use the GC space node as opposed to just creating spaces in Ecosystem Building Designer? This can actually be a great tool in the initial stages of a project when you're testing the space program against a concept design, for instance. It does create ABD spaces just the same as if you created them using Building Designer tools. However, these spaces can be associated with the geometry so that as you're modifying and changing your conceptual model, you're getting an update on the spaces as well. Spaces can be replicated using the GC space node, which means if you have to create a great number of spaces, for instance, doing an office layout or doing hotel guest room modules, you can create those all at once and keep track of counts and areas and so forth. And in so doing, then you can test various what-if scenarios and immediately evaluate the results of the changes in the model. So let's take a look at how that's done. So we're going to start here with some base geometry. We've got an arc that's controlled by 3 points, and we'll go ahead and place some spaces along the arc, perhaps some office spaces. So I'm going to scroll down and select the Ecosystem Building Designer space node and place that on the graph. Then I'll go ahead and rename that. We'll call it Space Office. And then we want to go ahead and select a catalog type and item for our spaces. So of course the type is space, and then we'll select the office enclosed. We'll go ahead and take a look at the techniques for creating spaces. For instance, we could do from polygon, but I think we'll use a point grid. By point grid, if we can generate a grid of points along the arc, then we can use those points to generate a series of spaces. So in order to do that, we'll place a point node on the graph. We'll call this one point grid, since this will be our point grid. And for the technique, we're going to want to use something that'll place points along the arc. There's several options. We could do it by spacing or by number of bays, depending what we want to control. We're going to link that then to the arc, put in the number of bays. For now, we'll say 10. And then we do have an option to do fractions of bays. We'll just leave that at 0 so we get full spaces. And you can see that generates a series of points along our arc. I'm going to add a second arc so that we can get a second set of points that represent the inside surface of the spaces. So I'll call this arc base 2. And then we'll use a technique of circular offset. Basically, it's a copy parallel. And the arc we're going to copy is the arc base. We're going to use by distance as our method. And then we just need to put in that distance. For now, we'll make it 10. Now, if it doesn't offset in the direction you like, simply make it negative rather than positive. Now, if we link that arc up to our point grid, we'll get a second set of points along that arc. And now we truly have a point grid, and we can link that back to our space node And we've generated a series of spaces along our arc. Should be 10 spaces because that was the spacing of our points. I'm going to switch that to deferred dynamics so that we can modify easily here, and I'm going to select one of our base points, just move it around so we can see what happens. So as I move that arc around, it's then going to regenerate the spaces. I'm still going to get 10 spaces, and now they're going to follow the new arc geometry. If we want to track a little more information on those spaces, we can go ahead and open up our Data Group Explorer and look at our space schedule. And you can see there it lists each space and gives us the actual area of each space, 89 square feet. We could also put in a count so we can see that we're getting the 10 spaces. And again, the actual area of each space is 89 square feet. And again, if I go back and modify my starting geometry, I can simply refresh the Data Group Explorer to immediately get some feedback on what the change in the geometry does to our spaces. We still have 10 spaces because that was the number we fixed, but the actual area of each space has now gone up to 150 feet because it's a much longer arc. And we'll record those transactions. Now, we may want to control a few more things about our spaces. For instance, maybe we would like to make sure the spaces met a certain area, say 100 feet, and maybe we'd like to be able to adjust that as we play around with the model. So we could begin to put some sliders in so we can start to control the dimensions of the space, the area, the width, the depth. So the first slider we'll call office area. So we'll make the maximum 200. We'll set a starting value of 100 and perhaps make the minimum 75 square feet. We could set the resolution to 5 feet. So that's our first slider. Let's set up a second slider. And we'll set this up for the office depth. So basically the distance between those two arcs. And again, we just set up some minimums and maximums. Perhaps make the maximum 20. And the minimum 8. And in this case, perhaps we'll just do a resolution of 1 foot. Now we could actually take that office depth and link it to our offset distance on arc base 2, and that would set our depth now, or our distance. Again, make it negative if we want to offset in the other direction. And now if I change the depth, it moves the offset distance of the arc, which changes the point grid and ultimately the depth of the spaces. Now we might want to go ahead and create what's called an expression node so that we can calculate the width. The width is basically a result of dividing the area by the depth of the space. So we're going to call the expression office width, and then we'll just type in an expression here, which will be the office area value divided by the office depth value. And that way we'll always know what the target width of the space would be in order to achieve the area that we want. So that would affect the number of points that we set in our point grid, or our number of bays, we can actually calculate out how many bays we would need along the arc in order to achieve the area. We start by using a round function so that we get a whole number, since this is a number, a count. And then what we want to do is figure out the total length of the arc and divide it by our office width. And that would give us the number of offices we could get along the arc. However, since we have two arcs, we really just want the average between them. So we could sort of take the center of the space. So what we can do here is write a little equation. We'll take the length of arc base, add the length of arc base 2, take all of that, so we put that in parentheses, and we're going to divide that by 2 to get the average between the two of them. And then we want to take that length, so again we're going to put now that value in parentheses, and we'll divide that value by the office width. And then comma and set the precision to 0 so that we get an integer, close our parentheses, and select OK. And now you can see how immediately we got a greater number of offices along the arc, but they will all have an area of roughly 100 square feet. Go ahead and open up the Data Group Explorer, and you can see that now we have 22 office spaces, all with 100 square feet. Now if we were to modify that office depth, instead of 15 feet we went down to 12 feet, we could immediately see what a change like that would do to our space layout. I simply refresh the Data Group Explorer, and now I can see I'm only going to have 18 office spaces, still with an area of 100 square feet. So by using the space node, we can test various scenarios and immediately report on the results of those scenarios.